Hi, today I want to present about inductively coupled plasma optical emission spectrometry, which is ICP-OES. What is ICP-OES? Oh, I know about it. ICP-OES, a technique in which the composition of elements in mostly water-dissolved samples can be determined using plasma and a spectrometer. Next, those are the components of ICP-OES that in a sequence. Next, there are some important parts in ICP-OES that should be known, which are sample, nebulizer, ICP torch, and monochromatic. So, this is the function of each part in this ICP-OES. Autosampler is to introduce the sample, nebulizer is to convert liquid to fine mist, ICP torch ionization is occur. Next, the function of monochromator is create single wavelength of sample, and lastly is detector is used to detect positively charged ion. So, those are parts of instrument that used in ICP-OES are compressor, argon gas, and regulator.
Henry, this is Susan and Katrina. They will help you make solutions to go into the ICP.
Oh, hey there, Henry. So there are a few necessary steps in order to make the solutions for the ICP. We're going to need a few different solutions in order to pick out the different species that we have in our mixture. First, we're going to prepare a sample and create a series of standards to compare it to. These standards and our sample need to be within an acceptable working range of concentrations. Otherwise, the ICP won't be able to read them properly, and then we won't get the results that we're looking for. We must create a set of progressive dilutions in order to build a working curve, keeping in mind the effective working range of the instrument, which is about 4 times the detection limit and all the way up to the linear range.
Where do you find this information?
Great question, Henry. So, whenever purchasing an ICP or using one, there is a specific appendix that will list all of this information, including the detection limits and the linear range. So, you have always the option to create these standards using 2 different dilution techniques, either by mass or by volume. And because of our specific preferences here at the Norway Valley Lab, we have chosen to do these dilutions by mass. Once these dilutions are made, we will then go ahead and fill up these test tubes just about 3/4 of the way, and then they're ready to go.
Now let's talk about what goes into the ICP. We will need a peak search solution, attenuate solution, and standards. To make these, we will create a range of progressive concentrations based upon existing literature and appendix values. We will make about 4 or 5 today. The peak search sets the upper limit on the machine, and it helps it shoot for the maximum of the range of values. We also need to make an attenuate solution tube. It gives the machine an idea of the actual peak maximum, narrowing down the range of it. Then, the standards follow a range from the attenuate to the smallest predicted concentration. These standards create the calibration curves for the individual species and solutions, which then we can use as a basis with which to compare the data from our samples. The sample must also be prepared at the correct concentration in order for the ICP to be able to detect it properly. This is a value always greater than or equal to 10 parts per million. This is how we find the concentration of multiple species within an unknown sample. All of these individual tubes need to be entered into the rack of tubes in a specific order. Make sure you plan ahead and label them well. The machine will read the rack just like you would read a book. It will draw from the top left corner and work to the right, before shifting back to the next row and reading across again.
Next, we are going to learn on how ICP-OES works. Firstly, the sample is transferred into the nebulizer. The nebulizer will convert the liquid sample into fine mist or aerosol. The mist is then directed into the plasma torch. The atoms and molecules are immediately atomized and ionized, and the emitted radiation from the excited ions can be detected and attributed to its corresponding elements. After that, before using the ICP-OES machine, the sample should be prepared. Then, for each element that we want to measure, a standard need to be purchased, and the standard solution of different concentration need to be prepared. After that, the sample can be poured into test tube. After that, over a pump system, the solution is sucked into the nebulizer to convert the liquid sample into mist or aerosol. The mist is then directly directed to the plasma flame. So, as you can see, this is the plasma flame. The sample is atomized in the flame and the emitted light is led over polychromator to the detector. The information can be obtained from the software on the computer. Operating ICP-OES is not easy and costly. We need high voltage, argon flow, sophisticated ventilation, plenty of space, skillful technician, and of course, a lot of money.
Next, the application of ICP-OES. First, the environmental and agrochemical analysis. Secondly, analysis heavy metal in cosmetic or pharmaceutical product. Third, analysis element in soil. And fourth, motor oil analysis. Continue with advantages and disadvantages of ICP-OES. For advantages of ICP-OES is fast and easy to use. It also measures wide range of elements and concentration. Furthermore, it's accurate and very low cost. Disadvantages of ICP-OES: it is higher detection limit and only liquid sample, which is consumed 2 to 5 sample preparation and spectral interference. For last, differences between ICP-OES and HPMS. For ICP-OES, the separations of ion based on wavelength of ion. Secondly, the method development is simpler and the cost is low. Moreover, it can detect 73 elements and no highly specialist is required, and it does not damage directly. How about ICP-MS? The separations of ion based on mass to charge ratio. Then the method development is a bit difficult compared to ICP-OES. Also, the cost is more higher. Furthermore, it can detect 82 elements and highly specialist chemist is required, and it can be damaged by direct sunlight. Oh, it's done. Thank you for watching. Bye.